Hey, what is going on, guys, and welcome back. And we're continuing with section 1 of part 6. We left off in the previous video covering this exercise. In this video, we're going to continue with the reading material, and then we'll try to do at least one or two of the remaining exercises. There's quite a bit um, of exercises left, and they're all kind of tied in together, and the last one is the most extensive. So we'll try to get through some of them, and the final video on section 1 will cover the remaining exercise should it take too long to get through all of the material that we need to get through in this video. So this uh, heading is reading the same file multiple times, and it says that sometimes it is necessary to process the contents of a file more than once in a single program. Let's have a look at a program which works with some personal data stored in a CSV file. And if you remember from last time, CSV stands for comma separated values, and it look like this. It will be just a document, and the values will either be separated by commas or, in this example, by semicolons. So um, so yeah, CSVs will be very common in your time when you're writing programs and when you're working in the industry. You come across CSV files a lot as a export file type for what your program outputs, what your program will use for inputs, and stuff like that. So this is our CSV file. It has, as we can see, names in the first column, integers in the second column, and then third column here has cities. So Helsinki, Espoo, London, Amsterdam, and Paris. So our program opens the people.csv file, which is this one, and it creates a reference to it as new file. So this is how we'll reference people.csv. Then we'll loop through the file for each line. So we'll say for line in new file. Then we take that line and we split it by semicolons. So now we have a list. So parts will point to a list of these values as the indices in the list. Then we print name parts 0. Okay, and then we go through the file again. So the file is still opened. We have a helper variable here called age of the oldest, set that equal to -1. And then we go through the file line by line again. We split the lines of each file again. And we assign name to parts 0, as we've seen up here. And then we set age to, so now we know that in our CSV file, the second column holds integers that are ages for each person. So in this parts list, the first index will hold the name, the second index will hold the age, and the third index will hold the city. So when we do age is integer parts 1, it's going to point to index 1 in the parts list, which will hold the age. Then we say if age is greater than age of oldest, we set age of oldest equal to age, and then oldest is equal to name. So we create a new variable called oldest and set that equal to name, and then we print the oldest is oldest. And then when we run this code, we'll get a cryptic error message, somewhat of a cryptic error message. It says we get a traceback error when we print the oldest is oldest, and it says unbound local error, local variable oldest referenced before assignment. So, right, so in this print statement here, right, this print block, since it's outside of the loop, it doesn't have access to this variable oldest. The reason this happens is that the latter for loop, again, which is what's going to be explained here, this second for loop is not executed at all because the file can only be processed once. Once the last line is read, the file handle rests at the end of the file, and the data in the file can no longer be accessed. If we want to access the contents in the second for loop, we'll have to open the file a second time. So essentially, when we're working with files, it's just natural behavior in Python where when we're looping through the file, once we've gone through the entire file, then that's it, right? Python doesn't go back up top. There's no reset mechanism. So you have to open the file, do what you want to do with it, and then open the file a second time and do a second thing with it. So this is, again, opening the file as we did up here to print the name, and then we'll have to open the file a second time to have access to this, right? To get the person's age and printing the oldest person. With the above code, while the above code will work, it contains an unnecessary repetition. It is usually best to read the file just once and store its content in an appropriate format for further processing. So here in this program, we have a variable called people, which references this empty list. We open the file, and what we do is we go line by line in the file, we split each line, and then we append tuples into the list. So, and I think it'll be nice to actually demonstrate this. So let's go here, for example. We'll just create test.py, and we'll create people.csv like that. We'll paste, where's people? There we go. We'll paste this in there, right? Close that pop-up. And then so let's look at the code. Okay, so we need to open the file down here. We need to open the file and then read it, print the names, and then open the file a second time. So we'll say with open people.csv as new file, and we'll say for line in new file, parts is equal to line.split, and then we say name is equal to parts 0. In fact, we could just print name. Right, so we can just get rid of this. So now when we run this program, it's going to open the people's file. We're in part 0604 course grading part 1 source file. So now when I do python test.py, so it goes through our, in fact, I think it might be helpful to have this open in the second side here so we can see it. So we open the file, which is this peoples.csv, and we're printing the names. So it prints Peter, Emily, Eric, Adam, and Alice, as you can see here, preceded by the name here. I'm sorry if I drop some frames. I think whenever I run the code, it kills a lot of frames. Okay, so that's the first thing that we needed to do. Now the second thing is to reopen the file and keep track of the oldest person. So now we're going to say, I'm just going to copy this, paste it, then we just set age of oldest, set that equal to -1, open the file one more time, loop the file again, split the files. Now we can set name equal to parts 0 and age equal to parts 1, like that. In fact, we need to typecast this. So, because when we're splitting the contents of a line, then it becomes strings, so we need to convert that string into an integer. And then we say, if age greater than age of oldest is equal to age, and then oldest is equal to name. And then we go down here and we print the oldest is, and then oldest. So now, when I clear this and run, it says the oldest is Adam, right? Adam is 100 years old. So now the next problem that this has to solve, which we solved in the last exercise that we covered on video in the previous video, was eliminating repetition, right? Abstracting a little bit. Now, abstraction is the idea of sometimes breaking down things into the smallest parts. So when we're looking at this program, we can see, well, we're opening the file here, right, to loop through it, and then we're opening it again here to loop through it. So why not make it easier for ourselves in which the first time that we open the file, we can store what we read from the file into a helper variable that we can then reuse later on. Say, for example, we need to do other stuff with the contents of a file. We don't want to keep reopening the file. So while the above code would work, it contains an unnecessary repetition. It is usually best to read the file just once and store its contents in an appropriate format for further processing. So we add this helper variable called people, which is assigned this empty list. Now, when we open the file and loop through each line in the file, split each line, then we append to our people list a tuple of the various indices from this line split. So now this becomes people.append parts 0, parts 1, parts 2. Then we can print out each person, right? Because that's the first thing our program does. It prints out the first person, each person's name. So, in fact, I'll just write it out. So for person in people, print name followed by person at 0. So now when we run this program, we still get our names being printed out, right? So we don't have to, we didn't have to have everything done over here. Now people, right? If we print people, we'll see that we get this list of tuples, right? And each tuple contains a name, the age, and the city. Now everything is stored as a string, so whenever we're working with integers here, for example, we'll have to typecast. But for now, as you can see, we have this list that contains all the contents that was inside of our CSV file, and we can now work with it a little bit easier. So now the same thing here, right? Instead of declaring age of the oldest person inside the loop, we can declare it outside the loop, right? And we don't have to open this file again. And now we can say for person in people, right? You can still say name, person 0, age, person 1. Then if age is greater than age of oldest, we set that as the current age, or the age of the oldest person, and then we set the name to the oldest. And now, when we run this program again, we still get the oldest is Adam. So what we've done here is instead of having 2 instances of us opening the file and doing something with the content, we read the file just once, save the contents of the file in a format that we can work with in a list, right? The list that contains tuples, and then from there we can reuse that list every single time we need to access information about the content we just read. So hopefully this helped make things a little bit clearer. Now again, we did this something a little bit similar in our previous exercise here. I'll just open it for a second in this matrix one, right? We created this function that opens the file and creates a matrix for us, and then we reference that matrix in the subsequent functions that we had to write to determine the sum of the matrix, the largest number in the matrix, the sum of each row in the matrix, right? So this is basically what this is demonstrating, right? We're breaking down bigger programs into smaller parts that make reusability a little bit easier. So hopefully that helped clear some things up. So I'm just going to pause it. I'm just going to delete this stuff. Actually, no, I'll just close it for now. We don't really need to reference it again, but yeah, so hopefully that helped make some sense of what was going on here. Okay, more CSV file processing. Let's continue with the file grades.csv, which has the following contents. So grades.csv has names in the first column, followed by, for each line, these integers that mean the grades that a student got for, I guess, either exams or for their classes. So we have Paul followed by his grades, Beth followed by their grades, and Ruth followed by their grades. This following program creates a dictionary grades based on the contents of the file. The keys are the names of the students, and the value attached to each key is the list of grades attained by the student. The program converts the grades to integer values so they can be processed easier. So here we have this variable grades, which is assigned this empty dictionary. We open the grades.csv file, and we reference it as new file, and then for each line in the new file, we loop through it. First, we get rid of the new line characters. So as you can see here, let me go back to people. So each time, right, we go to a new line, there is a carriage return or a new line character here. This is how programming languages process new lines. So this gets attached to each string. And if you remember when we were looking at tests, right, when we were printing stuff down here, right, if I do Python test.py again, I'm sorry, not this. If we go back to test.py and we printed people, you will see it, right? You see this, right? So at the end of each line is a city and then a new line. So as you can see where we store new cities, right, we get this carriage return. So you could take care of this by doing line is equal to line.replace like that with an empty string. So now when we print the people again, you'll see that we've gotten rid of, I'm sorry, Python test.py. As you can see now Helsinki, right, each city doesn't have that new line character. So that's what this is doing here, right? It's getting, first before we split the line into our list of parts, let's get rid of that new line carriage return, right? That new line character. Replace that with an empty string. So as you can see, now over here in an example, each city doesn't have that backwards slash followed by the n that symbolizes that we need a new line. So each time there's a line break here, there is an invisible this at the end of each line that programming languages will interpret as meaning, hey, at the end of this line, go to the next one. At the end of this line, go to the next one, and so on and so forth. So we get rid of the new line character, and then we split the line by semicolons. We grab the name, which will be the first item in the line. Then the grades would be, so we set grades at name, so name becomes the key, and the value that the key is mapped to will be an empty list. And then we loop through for grade in parts, right? So for parts from index 1 to the end, append to this list that value, that these numbers, as an integer. So now when we print our dictionary, it'll print the key as the name of of the student, and then mapped to this list of all their grades. So it'll do Paul, it'll do Beth, and it'll do Ruth. Now we can print out some statistics on each student based on the contents of the dictionary grades. So for name, grade list, and grades.items. So the best we can, so grade list references the value that the key is mapped to in our dictionary. So we can get the best grade by using the max function in Python, right? It's a built-in function. We can use it. We can give it a list, and in that list, we'll find the largest value. Then we can get the average by using the sum and the length functions like this to get the average. And then we can print the name of the student. The best grade is that best, and the average is 4.10. And we can format the floating point number to 2 characters after the decimal. Please take a careful look at the programming example above. It may seem a bit complicated at first, but the technique can be used on files containing many different types of data. So I think this was pretty simple. And again, I'm sure the exercises that we're going to cover in this video will have some similarities to what we just seen here. So always when you're doing exercises, just be mindful of the content that you're reading because they are a great reference point for when you're doing the exercises. Okay, removing unnecessary lines, spaces, and line breaks. So this is what we learned a little bit earlier, like something like this, right? Getting rid of the carriage returns, the new line characters. Let's assume we have a CSV file containing some names, which has been exported from Excel. So it's telling us that the first column contains the first name, the second column contains the last name, and then every line after that will have the person's first name, last name separated by the semicolon, on and on and on. Excel is notorious for adding extra white space. So these spaces between between characters, right? So after a semicolon, there's a space, and then we get an alphabet character. Here we have an extra space character between the items after each semicolon. We would like to print out the last names of each person on the list. The first line contains the headers for the data, and it can be safely ignored. So here we create a helper variable called last names, which is assigned this list. We open the file, reference it as new file in our code, and then we loop through each line from the file. We take each line and we split each line by the semicolons into this variable parts, which is going to point to a list. So first semicolon space last becomes first comma space comma last. So we want to ignore the header line. So if parts 0 equals to first, continue, right? So essentially, if our list has this, if the first item in our parts list has this string first, then don't do anything, right? Just go on to the next thing. And then we can append to our last names list the parts at index 1. So index 1 will be this last. So executing, and they have a misspell here, and then we can print the list here. So executing this will print out Python, Java, and Haskell, right? So these are our last name, Python, Java, and Haskell. The first two items have a line break character at the end, and all three have an extra leading space character. So here, there's a space, here there's a space, and here there's a space. And in this, in the first index, there's this new line character, and the second index is also this new line character the last one doesn't have. So we have already used the replace method to remove extra white space, but a more efficient solution is to use the Python string method strip, which removes white space from the beginning and end of a string. It removes all spaces, line breaks, tabs, and other characters which would not normally be printed out. So you can try it in the Python console like this, and you can do that on your window. So if I just write Python, it's going to open this interactive Python environment for us. And if I do, for example, a space like 3 spaces, hello world, like that, and I do strip, and then now it just prints, it removed all these beginning empty spaces from our string and just return a normal string like this, hello world with a space in the middle, right? And we can try this again. We could do, new character, test, new character, bunch of spaces, and then strip again, and then we just get the string test in one line. Stripping the string requires only a small change to the program. So, again, we have our helper variable last names, which is assigned this empty list. We open our file, create the reference to it as this new file, then we loop through the file by line. We split the lines by the semicolons. We skip the header, right? So if parts 0 is first, we bypass it, right? Continue on to the next line, to the next item, and then we can append each item after that, like this, and then we attach this .string method to the string name, right, to the last name, so that way it will get rid of these new character symbols, and it will get rid of these leading spaces for each string. So now when we print last names again, we get them cleaned up like this. There are also related string methods called lstrip and rstrip, which I'm assuming will be left strip and right strip, right? So they remove only the leading or trailing unprintable characters. L is for left edge of the string, and R is for right. So left edge strip and right edge strip, this will remove only spaces when we use it like this, right? R strip, so like that, you can see it got rid of all the spaces after our last alphabet character. And then if we were to do it with L strip, like that, we can see it's removed the first space character before our first letter, and then it left the ending like that. So .strip, right, the strip method as itself removes everything from the beginning to from the end. rstrip is if we want to focus just on the right edge of our string, and lstrip if we want to focus on the left edge, the leading edge of our string. So hopefully that helped clear that up. If you have any questions about what we learned so far, leave it in the comments below, and I'll try my best to help you understand a little bit better. I think it might be worth if somebody does have trouble, I'll create a little exercise that we can use to practice this a little bit more. But yeah, so if you have any questions, leave it in the comments below, and I'll try to the best of my ability, the best of my abilities, to help you understand the material a little bit better. Okay, combining data from different files. It is very common for the data processed by a program to be scattered in multiple files. This is very true. This is something you will come across a lot in your programming journey when you be, in industry, in college, in which you might have to use multiple files to build a more comprehensive uh, collection of data that we're going to use for our programs. So let's have a look at a situation where the personal details of the personnel of a company are stored in a file called employees.csv. In this file, we have a first line, which is the header, right? This is what tells a reader what each column in each line represents. So in this instance, the first column will be the PIC, second column will be the name, third column will be the address, and right, so Vipulanti 7, and then the final one will be the city. The salaries are stored in a separate file called salaries.csv. And again, this file also has its header. And here it has, I'm assuming is that person's ID number, followed by their salary, followed by whatever bonus that they get. So here, the ID number, their salary is 3,300, and the bonus is 0, and so on and so forth. Each data line in both files contain the personal identity code, which identifies whose data we are dealing with. Using the personal identity code as a common factor, it is easy to connect the names and salaries of each employee. We can, for example, print out the following list of monthly incomes. So incomes, right? Pekka Mikola, their salary is 3,300 euros. Lisa Martinen, right? The second person here, their salary is 4,350, right? So it's their salary plus their bonus. And then here we have Arto Vihavinen. Their salary is 2,500, which is 1,300, their salary, plus their bonus. So their income will be 2,500 euros. This program uses two dictionaries as helper data structures, names and salaries. Both use the PIC as the key, or the personal identification, what do they call it? Identification code. So names, we have this helper variable names. We open the employees files, we loop through it, we split each line, and then we look for the first line being the header, and if it is, then we skip. And then for each, then in the names dictionary, right, the key will be that person's code, and then the parts will be, what's the first file? So this will be their name. And then we have this helper variable salaries. We open the salaries file. We do pretty similar things, and then we assign their salary, their income, as integer conversions of their salary plus their bonus. And then we can print incomes, and then we can loop for personal identification code and name in names that items. If the personal identification code in salaries, right? So if this is in this dictionary, then we can print their salaries. We can print their name and their salaries, etc., etc., etc. So first, the program reduces the dictionary's names and salaries. They have the following contents. So these are the dictionaries. Each key is the personal identification code. And in the names, so this is the names dictionary, which has mapped to that person's name. Same thing for all the other, for the remaining people in the names file. In the incomes dictionary, again, we save their dictionary as the key, and their income will be their salary plus their bonus. So we can reference them, right? Hey, we're currently going through the names dictionary. We're looking at this personal identification code. If this personal identification code exists in the salaries dictionary, then go ahead and print their value. The for loop at the end of the program combines the names of the employees with their respective salaries. The program also takes care of situations where the employee's personal identification code is not present in the salary file, right? Else, print their name and then €0. Remember, the order in which items are stored in the dictionary does not matter, as the keys are processed based on the hash values. Okay, so here we have our first exercise, and we're about half an hour into this video. We're instructed that this program works with two CSV files. One of them contains information about some students on a course. Okay. The other contains the number of exercises each student has completed each week. Okay. As you can see above, both CSV files also have a header row, which tells you what each column contains. Please write a program which asks the user for the names of these two files, reads the files, and then prints out the total number of exercises each completed by each student. If the files have the contents in the examples above, the program should print out the following. So prompt the user to input the student information file, and then the exercises completed file, and then it prints their names, followed by the number of exercises they completed for each student. Hint, while testing your program, you may quickly run out of patience if you always have to type in the file names at the prompt. You might want to hard code the user input like so. So you can do it this way, right? If false, so this never runs, so that way student info and exercise data are always assigned these values respectively. The actual functionality of the program is now hidden in the false branch of an if statement. It will never be executed. Now, if you want to quickly verify the program works correctly, also with user input, you can just replace false with true. So if true, then always run this. So this might be pretty helpful for us. So I'm just going to copy this, actually. When you have verified your program works correctly, you can remove the if structure, keeping the commands asking for input. This exercise doesn't ask you to write any functions, so you should not place any code within an if underscore name equals main block. Okay, so I'm going to close this and close that. So course grading part 1, just going to paste that there. Then we're going to then need with open student info as students file. I did not mean to run the program here. Let me just close this. Then we're going to say for line in students file. We're just going to print the line. So this is just how we can test that our code so far is working. So if I run this, okay. Oh, I got to exit this. There we go. So let me run the code. Okay, I guess we might want to run this manually. Course grading part 1.py. Okay, so it prints the ID. So students 1, which is this file, and exercises 1, which is this one. Okay, so it prints the header, and it prints each line, which has their ID, their names, their first and last name. So what we need to print is their first and last name plus their exercises completed. So here, students is equal to this empty dictionary. I say line dot split that line is equal to line dot split. And then we don't have to worry about stripping any, actually, we probably do. Then we'll say students name is equal to, not line is equal to, I'm sorry, we have to do parts is equal to line dot split. Like that. Then we say name is equal to, actually, if parts 0 is equal to ID, and continue, then we're going to say students at parts 1 dot strip. In fact, actually, we should probably do this. Is equal to an empty list. And then we're going to say print students. So now we have Pekka Peloton, Jana Javainen, and then Lisa Vertanen. So we opened the first file, looped through it, and appended their names to this student's dictionary, which is so far so good. Then what we need to do is open the file, a second file, as for line in exercises file parts is equal to line.split if parts 0 is equal to, what's the heading for this? ID. Continue. If parts 1 should be their ID. I'm sorry, if parts 0 is equal to in students, then students at, oh right, I just made a mistake. The key should be oh wait, I need to think about this. Hold on a second. I think the key, what we're doing is we're setting their names as the keys. But we should be setting their IDs as the keys. That's the wrong file. I think we should do parts 0.strip. So let's run this program, see what happens. What's the problem? Right, so now we have their ID. That way, then we can say if parts 0 in students, then we can say students at parts 0 is equal to that append. We'll do this tuple, and this will be parts 1 onwards. So let's see what this does. Okay, so now we have this. So now we have IDs which point to this this list of their exercises. So I was sitting here thinking again. I just took a second to think about it. And one thing that I remember as I'm writing the code is that, so my idea was this, right? We have the student's dictionary, and for each student, we'll have their ID number as the key, and a tuple that will hold their first name, last name, and a list of all their grades, like that. Now the problem with this is because both files hold two different types of data, similar but different. The student's file only holds the student's ID followed by their first and their last names. The exercises holds their ID followed by each grade, right? That these students each exercise that they've done. So what instead we're going to do is keep the student's dictionary like this as a tuple with keys mapped to tuples containing their first and last names, like this, but have a second dictionary that's going to hold the exercises. And in that one, we're also going to store each student's ID as the key, and then a list that contains all their grades as the value that that the key will be mapped to. So hopefully that makes sense. And the problem with this again, because tuples are immutable. So once we create our first tuple here that has the first and last name, we can't come back into the student's dictionary and get a key and try to append more data to the tuple. We can't do that. Once you create a tuple, the information that it contains is final. There's nothing we can do about it. So I think that's probably the better approach. So here we're going to say if parts 0 is equal to ID, continue. Then we're going to say exercises parts 0 is equal to a list that contains parts 1 to the end. So now when we print students and we print exercises, we should see two dictionaries, one that will have, and I'm sorry, this needs to be the student's name, I mean their ID, which we don't need to even worry about, strip like this, which will have a tuple that contains parts 1 and parts 2, right? Because here parts 1 will be the first name, and parts 2 will be the last name. So let's do this and see what happens. Okay, so our first dictionary here has the first name and the last name as a tuple. But for the second one here, we're just gonna have to do strip to get rid of that line carry, the new line break. So again here, when we run this, now we get first name, last name, and we don't have the /n for each student. And then for this one, we get student IDs followed by this list of their grades. But the only problem here is this, right? We're creating a list inside of a list. So let's do this. There we go. Now we have each student's grades as in a single list. So we just have to take care of this. First, each value needs to be an integer, and we need to get rid of these extra line breaks. So what we can do from here, we can create a helper variable called numbers, or I should say exercises. And we'll call it numbers. So that equals to an empty string. Then we'll loop through for exercise in parts 1 to the end. So for every value after the first one, so it'll be from index 1 to the end, to just do this, numbers that append integer exercise, like that. And then we'll say exercises at parts 0 that is equal to numbers. So now when we print our students dictionary and our exercise dictionary, we should get two dictionaries. So the first one has tuples for each person's first and last name, like that. And then the second one has, again, same IDs, followed by lists of that person's integer, like that. And another thing what you can do here is just do line.strip.split. So that just guarantees that we won't have any new characters added or any unnecessary spaces added. So again, if we do that, again, we should see that it still works. But because we did type conversion here anyways, it got rid of it for us. So this is just extra security, but it's not really necessary. So now we have these two dictionaries that have our students. Each key in the dictionary is a student ID. In the student's dictionary, the values mapped to each key are tuples of the first and last name. In this one, again, student IDs are the keys mapped to these lists of exercises. Okay, so what's next? What we have to print out is the first and last name followed by the sum of the exercises that they completed. So we'll go back to here and we'll say for student in students, and then we say first name comma last name is equal to student. So that's how you unpack a tuple. And then we'll just print first name comma last name, like that, just to see if this comes out clean. Interesting. Let's do print student and see what this does. So it prints the IDs. So so that would be print students as student and see what this prints. There we go. Now we'll get their first and last name. So we can then say first name, comma, last name is equal to students at that student. And then we can print their first and last name like that. There we go. Pekka Peloton, Jenna Javainen, and Lisa Vertan. Hopefully I said those correctly. Now we need to print their grades right next to them. So instead we can just turn this into an F string like that. Wrap this, space, wrap that. And then we can say for grade, I say exercise in exercises. I should say we probably do if student in exercises. Then we'll print that, and then we'll do exercises at student, and then this will be the sum. Sum like that, and now when we do this, I think this should work. There we go. Pekka Peloton, 21. Jenna Javainen, 27. And then the last person has 35. Let's see the values here. And just like that. So now, the last thing that we need to do is set this to true. And then when we run our program, we should be prompted. So now we can say students1.csv and exercises1.csv. And then boom, we get the full printout. So this should be our final solution. So as you can see that we really just worked through the problem, right? First, we were just going to have one dictionary of students. Each entry is going to have their ID as the key. So 1, 2, 3, 4, whatever. And it's going to be, now originally the idea was to have a tuple that has their first name, their last name, followed by this list of all their exercises. Like that, for example. But we remembered as we were doing this exercise that tuples are immutable. So we need to first know what data that we're working with before we can do anything with it. So what did we do? We decided, okay, we're going to keep the tuple mapped in the student's dictionary, mapped to each student's ID, right? But we'll create an additional dictionary called exercises, which will also have the student ID mapped as the key, mapped to a list that has all their grades. Because we know that at the end, when we can loop, we can use the ID as the matching entity to the second dictionary. So since each entry in both dictionaries have the same ID, we can map them together, right? We can use those as a way to reference the other dictionary. And that's how we're able to print this. So in fact, here, if you want, you could probably do exercise grades is equal to sum exercises student, like that. So student here, as we saw earlier when we first printed what student was, is the ID. So we say, hey, go through the exercises dictionary, find that ID, see what it's mapped to, and get the sum of that list of the items that this maps to. And then here you can just inject grades like that, right? But that's just a little bit extra. We can just leave it like this. So that should be the solution to this exercise. Like that. And we can run our tests. And there we go. Send that solution to the server and open the model solution in the browser. Like that. And there we go. So they did this way, right? Prompt the user for their name, for the files, have a student's dictionary, a exercise dictionary. So what they did is just, instead of assigning a tuple, they just assigned a string that strips the last name from any additional characters. So spaces, new line characters, etc. So that's what it's mapped to. So the key will be the student's ID, which is mapped to the student's first and last name as a full string. Then they have an exercise dictionary, and they do the same thing. They open the file, go through each line, split each line, right? If we go through the ID, skip it, then here they have the, and this is probably even something a little bit cleaner that if you wanted to do, was instead of mapping each answer, each value as a list, instead what you can do is map the sum of each value of each student's grades and assign that to the student's key, right? So this will be a student ID mapped to a single integer over and over and over again. So, but we did it this way because we're having a little bit more forethought in saying, hey, maybe we want to do something else with these variables, with these values, right, with these grades. So instead of just summizing everything and then assigning that summation as a single integer to our secondary exercise dictionary, why not just put all the values as in a list and then have that list be mapped to the student's ID. So in the future, for example, if you want to do something else, maybe you want to get the sum, you want to get the highest grade, you want to get the lowest grade, you want to get an average, right? You can still work with that list to get all those additional data. But yeah, so this is the solution that we did. I think it's pretty good, pretty fair. And yeah, so if you have any questions, you can leave it in the description below, in the comments below, and I'll try my best to help you out. We can go back to the exercise page, refresh, make sure we got credit for that one, and we can continue. So exercises 2, 3. So yeah, exercises 2 and 3 go together, and we're about close to an hour into this. So what I'm gonna do is I'm gonna read this off screen for a second, off video for a second, see if we can finish 2 and 3 in the next like 10 or so minutes. If not, we'll separate this into its own video. There was a lot of reading material we had to get through. So maybe what I'm thinking, probably what I should have done is leave these exercises for another video. But because there was no exercises prior to this part, it was all just a bunch of readings and me going through examples, I thought it might be best to still do at least one exercise in this video. So let me read this instructions off screen and see if this is attainable in at least the next 20 or so minutes. Okay, so I read the instructions. This isn't a difficult exercise. It's difficult, but I should say it's not hard, but it is difficult. It's challenging, I should say. So this definitely requires me to just take a little bit of time to think about this a little bit more in detail about how we're going to approach this. I've also went back and looked at the CSV files. So for this one, which will probably be this one and this one, but there is no exam points 1 unless it's in this folder. Okay, it is. So it's in this folder. So we're gonna leave this for the next videos. Exercises 2, 3, then the spell checker one, and I think this one, because it's the one of. So the next maybe 4 or 5 exercises might be in the same video, which is what I anticipated will probably happen at the beginning of the video, like I mentioned, because of the amount of readings that we had to do. It'll probably make more sense for us to divide this section into 3 parts. So parts 1, we got through a lot of material and some exercises. Part 2, we got through a lot of material plus only 1 exercise. So the next video will hopefully be us covering the remaining exercises because there's no more readings between here. It's just all exercises. So hopefully we can get through that in one sitting, and then we'll be done with section 1, and then we can move on to writing to files, which is section 2. So if you have any questions, because we learned a lot and we practiced a lot and we did this exercise, so if you have any questions, feel free to ask them in the comments below. Don't hesitate, right? Don't be nervous, don't be scared. I'm here to help. So ask it in the comments below, and I'll try to the best of my abilities to be able to help you, continue to make progress. In the next video, hopefully we'll get through the remaining exercises, and after that one, we'll be done with section 1, and we can move on to the next section. Please don't forget to give this video a thumbs up. Subscribe if you're new. Check out the description. The GitHub repository will have all the solutions to all the exercises we've covered from the beginning of the course till now. 4 months of solutions. It's a really good reference and a really good collection of knowledge and information that you can use when you're studying. So take a look at it. Compare those solutions to what you've come up with. Again, if you feel like you're stuck or you're not making progress, remember, you only have to complete 25% of each part, right? So if we're in part 6, right, and there's only 19 exercises, and we've done, how many now? We've done 4, right? We only have to go through maybe like, perhaps by the end of the chapter, I mean, by the end of the section here, if we complete all these exercises, we'll be done with the requirement. So if you just want to breeze through this course and you don't want to go through all the nitty gritty of all the exercises, you just have to complete 25% of each part and you'll be good to go to have access to taking the exam. So if that's the case, then it should probably tell you that the exam isn't probably that difficult. But I still strongly recommend that you go through every exercise, because every exercise is good practice, and good practice is going to make you into a better programmer. So, yeah, link in the description for solutions. If you have any questions, make sure you ask in the comments below, and I'll be sure to help you out. I'll see you guys in the next video.